Hey guys, in a previous episode I showed you how to control a linear actuator using an L298N motor control board along with an Arduino, and as promised in this episode we're going to mix in the RC transmitter so that we can control the actuator from a distance. For those of you new to my channel, I would encourage you to take a peek at my other videos, and if you like what you see, do me the favor, hit the subscribe button and help my channel grow. If you haven't already, you may want to watch the other video first as we go into a little bit more depth of how everything works. And if you have any questions or comments, please leave those in the description below. In this video, I'll be using this Dumbo RC 6-channel transmitter and receiver system that I just picked up for about 30 bucks. We'll see how it works. Supposedly, it will transmit about 1,000 feet. I'm going to be using channel 1, which is the steering wheel. To extend the actuator, I'm going to turn it clockwise and to retract counterclockwise. The way these receivers work is that on this row of pins right here, each channel will output a pulse between 1,000 and 2,000 microseconds, and we'll use the Arduino to measure that pulse width. When the transmitter is in the neutral position, the receiver should output about 1,500 microsecond pulses. When I turn this to the left, it should increase to about 2,000, and when I turn it to the right, it should go down to about 1,000. Now these values, of course, are approximate and will vary with each transmitter-receiver combination that you have, but some transmitters have the ability to make adjustments. With this transmitter, for example, I'm able to reverse the direction. I can also adjust the pulse width of the neutral value when the stick is in the neutral position. And I can also adjust the high and low values using this control here. The first thing to do is to test the receiver by connecting it to the Arduino. The pin on the right will be ground, the one in the middle will be 5-volt power from the Arduino, and the orange wire on the left will go to our digital input. On the Arduino, I've connected the red pin to the 5-volt terminal and the black to ground. I've also connected the digital channel to pin 7. Let's write a quick Arduino code to test the receiver. This first code will be very simple. First we need a few integers. The first one is our RC integer, which corresponds with Arduino pin 7. We're also going to have a pulse duration integer. We're going to start our serial monitor and declare our pin as an input, and then we're going to measure the pulse width on that RC pin. We're going to trigger it when it's high and see how long it takes before it goes low again. So we will then print the duration to the serial monitor and then repeat every half second. So I've launched the serial monitor. Right now the transmitter is not on. Let me switch it on. We can see that while the wheel is in the neutral position, we're reading about 1,500 microseconds. And as I turn the wheel slowly to the right, that number decreases until it reaches below 1,000. I turn it to the left, it increases just above 2,000. Now that we know that our RC transmitter is working correctly, we can modify this code to include the commands for controlling the actuator. So we're going to add 2 more pins, one for extend, one for retract, and we're going to connect those to pins 10 and 9 on the Arduino. We're going to declare those pins as outputs, and we're going to initialize them low because we don't want the actuator moving until we've given it a command. Now let's talk about the loop. You'll notice that I have the same pulse in command that I had before, but I've constrained it to be between 1,000 and 2,000. So any value below 1,000 will get thrown out and reset to 1,000. Any value greater than 2,000 will be thrown out and reset to 2,000. All right, now for our first if statement. If we are in the neutral position, we should expect a pulse width of about 1,500. So I'm checking for that with this if statement here. So if we're between 1,400 and 1,600, I'm commanding it not to extend or retract. If the wheels turn to the left, we should expect a value greater than 1,600. We're going to command the extend pin to 0, and we are going to then map the value between 1,600. We're going to reset it to a pulse width between 51 and 255. And what this does essentially is the minimum value will be about 20% power, the maximum value 100% power, depending on the position of the stick. As we turn the wheel to the right, we expect our duration to get smaller and smaller. So in this scenario, we're going to command the retract pin not to do anything. But the extend pin, we are going to command a proportional speed based on the position of the wheel. So we're going to use that same map command, but this time we have the larger number first and the smaller number second. That means that as the number gets lower and lower, the pulse width value will get higher and higher. Finally, we'll set our delay to 100, which will allow this loop to repeat about 10 times per second. So let's go hook everything up and see how it works. I'll put the pin out in the video description and on my Facebook page so you can check it out later. But let me talk you through it really quick. We have 12 volt power coming from the battery to the L298N board. From the board we have a 5 volt DC coming to our breadboard. That 5 volts is connected to the 5 volt pin on the Arduino and the ground pin. And it's also powering our transmitter, receiver I should say. The output of the receiver is still connected to pin 7 on the Arduino, and pins 9 and 10 are going to the In1 and In2 connection on the L298N board. Also we have our actuator, positive to out 1, negative to out 2. Okay, let's test this out. So if I turn the wheel to the right, the actuator extends with variable speed. If I let go, it stops. If I turn to the left, it retracts, also at variable speed. Here I go from across the room. Well, it seems to be working great. This is a good demonstration of what you can do with an Arduino. The only problem is now I have 5 more channels on this transmitter. If you have any good ideas for me, please leave them in the comments below. As always, thanks for watching.